Hi there, I'm Eimear, a PhD student at the University of Oxford, and I'm here to explain to you what exactly is a particle accelerator. Well, the clue is in the name. It's a machine which accelerates particles, by which I really mean gives them more energy. The biggest particle accelerator in the world is the Large Hadron Collider on the French-Swiss border. This huge machine is a giant circle, 27 kilometers around and 100 meters underground. At a few different points around the ring, particles are smashed together and we use detectors to see what comes out. The first thing we need is particles, by which I mean subatomic particles, like electrons or protons. The LHC uses protons. We find these in the nucleus of hydrogen atoms, which are made up of one positively charged proton and one negatively charged electron. Because opposite charges attract and like charges repel, we can apply a voltage to rip these apart and use just the protons in the accelerator. Next, we accelerate the particles in the exact same way. We apply a huge voltage of 13 million volts in radio frequency cavities, where the particles ride electromagnetic waves, like surfers, until they reach almost the speed of light. We now need to control this beam of really fast-moving particles. For this, we need a huge magnetic field, which in itself needs an enormous electric current. This could make our magnets really hot if there's any electrical resistance, and magnets which catch fire aren't much use to us. To avoid this, we use superconductors, which only work when they're really cold. In fact, the centre of the LHC magnets is one of the coldest places in the universe, even colder than the outer space in between galaxies. The next stage is to collide the particles, which can be pretty tricky since we're trying to collide two beams of protons, each about the thickness of a pencil, as they zoom around a tunnel 27 kilometers in circumference. When this does happen, the two protons go into the collision and loads of completely different particles come out. Well, this sounds pretty strange. It's actually possible because of Einstein's E=mc² equation, which tells us that we can turn energy into matter with an exchange rate of the speed of light times itself, which is a huge number. In fact, this is why we need to accelerate the particles to such large energies, in order to make a tiny bit of matter after collisions. Finally, we need to use a particle detector, a kind of digital camera for taking pictures of particle collisions, to take a look at what we've made. An example of this is the Atlas detector, which is 25 meters tall, weighs around 7,000 tons, and can take up to 40 million pictures every second. We use detectors such as Atlas to answer questions such as, why is there more matter in the universe than antimatter? What exactly is the nature of the Higgs boson? Is there any new physics out there we're yet to discover? Some of the biggest science questions out there.